Cool. So tonight and tomorrow night, basically going through a mock exam. So um, as it will be in your exam, 25 questions. Let's see if we can nearly tonight get the session one component, questions 1 to 12 or 1 to 13 done. That will give us a good indication. And then tomorrow night, the next component, but the more we do tonight, the better. Um, but you will also now see in this, and like your mock exam was, that um, and I think what's important in your assignment, and that is 1510 and 1610, um, they ask nearly 13, 14 questions on 2 or 3 topics. In the exam, you're going to get 2 questions per topic. So nearly um, make sure that there's certain things that you need to know. So when we go through now the first few things, when we look at study unit 1, 2, and 3, going into 4 and 5, there's certain things that one must be very careful how they ask the questions. Um, be very um, looking out for things that they say, looking for the correct one, and then when the next question might be the incorrect one, but how they structure it is nearly that the first one is a correct answer. So just be nearly careful in those kind of things, because also that might happen in the exam. So just be on the lookout for that. Then specifically 1610, you can't go back to the previous question. So as we now do question 1, you need to complete it, do it. If you in the exam look at it and says, okay, what's the next question? You can't go back. Then you basically got 0 for the first question, and just makes it much more difficult to get a pass mark. So just be very careful in the exam not to skip questions or anything like that. And also, if you don't know the answer, rather than nearly see if you can eliminate 1 or 2 options, and then if need to, you guess the answer. But not to answer a question, then it's basically, you're going to get 0 for the question, where at least when you guess, there is an option for marks on it. So never leave a question completely out. The same if you see the timer, the countdown, and there's maybe 5 minutes or 6 minutes or something left, and if you have 3 or 4 questions left, if you feel that you can do one of them and have enough time for the rest, but nearly don't run out of time and not even have answered some of the others. Even if you guess the last 2 or 3, just try to at least submit the answer. And I think that's nearly what can make a difference of 4 marks, which can give you a pass rate or a rewrite. So nearly just when you look at those things, try not to not answer a question, kind of. Okay, so let's look at the first question. So they ask us, we're looking at these things, and they ask us which variables are qualitative, ordinal. They didn't need to tell you what it is. So in this instance, great, they tell you, well, Qualitative or ordinal is a categorical variable with an ordinal scale of measurement. What does ordinal scale of measurement mean? So that is nearly, what does that mean? If you see that, what does it nearly tell you what to look for? Okay, so when you see ordinal scale, it means there must be order in your variables. Okay, so we can nearly go through these and just say, yes, there's order, no, there is not. So economic sectors, agricultural, finance, manufacturing, mining, is there order in there? Yes or no? Cool, no. Okay, so by answering that first one, which variables are ordinal? So all of the above? No, because we know A is not one of them. A, B, and C? No, because we know A is not one of them. So if this was your last question that you needed to guess, and you only have 30 seconds, you've got 3 options left nearly to guess out of, by just looking at the first option. Okay, so let's look at the second option. Income groups, high, upper middle, low, and low. Order or not? Yes, there is order. So in the income, high, upper middle, low. Cool. So we know B is correct. B and C option, yes, it might be. B, C, and D option, yes, it might be. Only C, wrong, because we know B is also correct. So already by just looking at 2 options, we actually have eliminated 3 of your answers already. Let's look at the next one. Small, medium-sized enterprises are classified as micro, very small, small, medium-sized. Ordinal, yes or no? Cool. Getting a lot of yeses. Yes, correct. Okay, so we know, well, again, it's between 3 and 4 still. So if we get D, we will be able then to answer what the other 2 is. Types of degrees. Bachelor's, honors, master's, doctorate. Order, yes or no? Okay, so you first do a bachelor's, then you do an honors, then you do a master's, then you do a doctoral. There is order. So the answer is option 4, B, C, and D. We didn't even look at E because that's not in any of the references. But let's look at E, types of matric exams. So if you're writing independent or if you're writing the national senior certificate, any order in that? No. Okay, so there's no order in if you're writing the one or the other. Okay, so yes, there's 5 options, but nearly like if you just do it step for step, eliminating, very easy to start seeing, okay, well, if by just doing A, I eliminated 2 of them, and then I would just look at options B, C, and D. And by just looking at those 3, I then identified the one that I needed to do. But be careful in the sense they don't need to tell us it's categorical and it's ordinal. You need to know by just getting the qualitative ordinal what it means. Okay, so very important that. So study unit one of the questions basically on measures of scale, and this one was specific on ordinal. Okay, so here we wanted which one is correct. Okay, so next one, which one is incorrect? So again, sometimes one assumes the same pattern, and now you look at the first one, you look at 4 scales of measurements is nominal, ordinal, interval, and ratio, which is correct. So if you again said which one is correct, option 1 would have been your option, and you would have just gone on without realizing, oh, I'm actually looking for the incorrect one. So that's nearly the first thing. Just be very careful answering that. Take that extra 30 seconds nearly, read, look for that. Am I looking for the correct one? Am I looking for the incorrect one? Without making assumptions nearly what they want out of a question. Okay, so let's look at the second option. For an ordinal, interval, and ratio scale, the order of labels or values is known. So for ordinal, yes, we know the order is known. Interval, remember, interval is say something that will show you, so 1, 2, 3, so it shows you distance between two numbers. So it's definitely also known, and ratio also, so 2/3 versus 4/5. So we exactly know the scale of order, and it is known. So that one is also correct. For a nominal scale, so now remember, nominal order of attributes or labels is not known. Okay, so again, remember what is the ordinal, nominal scale. So something like, do you have brown, blue, green, gray eyes? There's no order in there. It is just a nominal scale. So nominal scale, order of attributes or labels is not known. Correct, because I don't know the order of somebody's eye color. I don't know the order if I were asking about which province do you live in, or things like that. So definitely your attributes or labels are not known. Okay, interval scale has no absolute value, while a ratio scale has an absolute 0. Correct or not? Okay, cool. Correct. So, and this is nearly one that afterwards nearly write this down, because this is the important one that you now nearly have, and don't need to go and study again. Write it down somewhere, mark it on a piece of paper as part of summary. Just write down interval scale has no absolute 0, while a ratio scale has absolute 0. Because that one is nearly for me a very important one that might come up again in an exam. So unfortunately, with this one, it took now a bit longer because all the first four is correct. So the last one will be incorrect, but let's just look at it. Nominal and ordinal scale measurements, quantitative variables, while interval and ratio scale measures qualitative variables. Okay, and so that is definitely not correct. Okay, so unfortunately with this one, nearly we needed to work through everything until we get to here the fifth question that was incorrect, but that will not be with all your questions like that. Okay, so that was nearly your first study unit, looking at measurements, or more the variables and the different types of measurements. 2 questions, that's it. Then we go into the next set of questions, which is then on study unit 2. So something like an absolute, where's that? Absolute zero. So think of a ratio scale as in temperature is a very good indication of a ratio scale. So temperature can be negative, temperature can be positive, with the absolute zero in the middle. So there can be a zero temperature where the interval scale can be kilometers that you traveled. Can't travel 0 kilometers, but you can travel 1, 2, 3, 4, 5. So, and you can't travel negative. So that is nearly the difference between the interval scale and the ratio scale with that absolute zero. There's not a lot of ratio scales that does have absolute zero. So temperature is one. Probably, what else can be, if you say something weird like height at sea level. So if you go up, it's probably positive. If you go down, it might be negative. Yeah, bank balance, that is always just in the negative. Bank balance is actually a very, 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 very interesting one. Yeah, so bank balance can be negative, positive, and at the beginning of a month, zero. So a bank balance is actually a quite cool one. So bank balance is a very nice ratio one as well, because yeah, I we just worried that I don't ever see the positive part of a bank balance. Cool. So that is nearly, if you look at absolute zero. So there needs to be negative, zero, and positive to that measurement. Okay, cool. So the next one, so study unit 2, going into tables and different ways of asking you questions around tables or visualizing data. So in this one, they said, okay, but there was a cyclone that hit Southern Africa in March 2019. Preliminary investigations reported a death toll at 1,005, with Malawi having 59 deaths, Mozambique 602, and Zim at 344. Now again, incorrect. So the previous one was incorrect. Again, going for the incorrect one. Total death toll stands at 1,005. Okay, that's the easy one. Vitality there. So that's correct. The percentage frequency of Mozambique is just below 60%. So we need to check, okay, Mozambique 602 divided by 1005. And then that is hopefully just below 60%. So let's check out. It's 602 divided by 1005 times 100, just to get percentage. So that is 59.9%. Okay, so that is just below 60, so also correct. Percentage frequency, so we're asking the same thing nearly. We just need to work it out for Malawi. So again, percentage frequency. So we need to make sure that we write it as a percentage. So cool, what is it, 5.87? Okay, so they say is less than 5, we get 5.87. So that one is your incorrect one, because it should be just more than 5, not less than 5. Okay, but let's just quickly relative frequency of Zim. So it is 333 divided by 1005. So relative frequency, not percentage relative frequency, so just relative frequency. So we don't multiply it with 100 or anything. So 344 divided by 1005 gives us 0.34. That is correct. Relative frequency. So again, relative frequency, not percentage, of both Malawi and Zim. So Malawi and Zim. So it is 59 plus 344, which is 403. So 403 divided by 1005 gives you 0.40, which is also correct. Okay, so cool. That's spot on, Martinez. That is so that is again, it's a small thing because it just less than or just more than 5, but one can easily make the mistake to say, okay, well, Mozambique 602 divided by that, so it's Malawi, so it might be around 5%, but it's just more than 5%. So that is the one that is wrong. Important here is to know the difference between, because they've never asked that, but I would have added something to say relative frequency and made something a percentage as well. But so important thing is when we say percentage frequency, the answer needs to be a percentage. When we only talk relative frequency, it is in a decimal format. Okay, so a bit more easier, but still you needed to do calculations. So again, you need to do at least some calculations with this. And again, this is not something you can really put in Excel or anything like that to work out. It will probably take you longer to work out in Excel than anything else, because you don't really know what the questions is beforehand. So something like this, I would do on my calculator and not even try it on Excel, because just so much easier to do it directly on a calculator. Okay, so that was one set of questions around a data table kind of. What I've realized is in this paper, there actually wasn't a stem and leaf. So just I'll probably pop one in for tomorrow night. But just go over the stem and leaf as well, because I think that is definitely important as well. So I will add in one for tomorrow night just to look at stem and leaf as well. So what they did, and this will also be part of when you write. So if you get a set of data and they say, but this is for questions 4, 5, 6, and 7. When you go to your next question, the data will be shown again. So it's not that, and you can see the next question, the data is there again, and the next set of question, the data is there again. So it's not that you getting the data for the first one and then it disappears. Whenever you need that data information, it will be there. What might not be there is here you are doing something with quartiles, and so it might be that for the next question, you might have wanted to use some of this, and then it will not be there. So again, for both 1510 and 1610, if you get something like this, where you know there's more sets or more questions on this data, what I would do with this one is I would just jot down Q1 was this, Q3 was, if I already calculated it in here, because it just might be that somewhere down the line, with this one being 4 questions, somewhere down the line it might be that you need something again. So something like this, now you see, okay, I've got some sample standard deviations, I've got variances, I've got the range. So it might just be, and in this instance, it was where the 7th question was coefficient of variation, which you need standard deviation and you need the mean. So it might have been that here standard deviation was already part of it. Not here was mean, so nowhere it asks about the mean, but at least if it was part of the things that you've done, you would have maybe jotted it down. Just and again, you don't need to do it, but it just saves time if it comes up. But again, if there's only one question on this data, then it's fine, because then the next question can't reference it. Okay, so here they tell us the data. The data is already ordered, so we don't need to do anything about the data. Nicely that it is already ordered from 1 to 9. So then, and I think this is very similar to nearly one of the questions that was in the mock exam, that somebody posted the picture of what was the interquartile range. So you could again see a lot of the same. We could have in here at the interquartile range. We just had a bit different things, but we have a position of a first quartile. We have a position of a second quartile. We've got the position of a third quartile. So already we could have had the last option as interquartile range or something like that. So now you can see with the mock exam that you guys, that's now open for you, very similar kind of questions. There's not, you can just ask that many things. So, or you can ask somebody to work out the interquartile range, or you can ask questions around Q1, Q3, positions of it, values of it. So then you don't ask interquartile range, but you ask everything else around it that you would have used in any case to work it out. So let's look at it. So position of first quartile is 3, and the value of the first quartile is 2. Okay, so as I showed on the group as well earlier, the position of Q1, the formula is n plus 1 divided by 4, which was 10 plus 1, so it's 11 divided by 4, which is 2.75. And then, please, for both stats 1510, stats 1610, you round that off. So don't work with a 2.75. That's how we used to do it 5-6 years ago when stats was still much more stricter with some of the things. But now we round it off because it's just easier to get. So Q1 position will be variable or number 3, which is correct, and the value is 2. Okay, so first one is correct. We're looking for whichever one is incorrect. Okay, so unfortunately we're looking for. Okay, so you can, so I nearly write for Q1, Q2. So Q2 is, so that's a formula is in the books. I don't know if it's in the study guide, but your formula is 1 times n plus 1 divided by 4 for Q1. For Q2, 2 times n plus 1 divided by 4. And for Q3, it will be 3 times n plus 1 divided by 4. And that's the formula. So you don't need to go into the detail of how we got to it. But a way to look at it is you've got 10 numbers. You need to divide it into 4 quarters. So that's why we divide it by 4. So if you look, so 25 divided by 1,000 is 1 divided by 4. 25 divided by 100 is 1 divided by 4. So it's just already simplified, where 2 divided by 4 is 50 divided by 100. And then Q3 would be probably 75 divided by 100, which again is 3 divided by 4. So why the book does it divide it by 100 is because it looks at it from a percentile point of view. So 100 percentiles in 1, where this already is nearly the quartiles that you're looking at. Oh, so does the book. Okay, so look also at, okay, that's interesting that the book says N. On what page is that on the, it might be because of
the simplified version.
Sorry?
Is it not the simplified version as 2 on 4 equals 1 over 2? Thus, the book refers to it as, or thus his query is n plus 1, because the simplified version of that will be 1 bracket n plus 1 bracket over 2.
Yes. See, I think where the n plus 1 comes in, and I will just make sure is also when you're looking at odd and even numbers. Because if this was 9, then 9 plus 1 gives me 10, so then it's easy to get in between the numbers. Let me just, because the n+1 is standard. So it might be that with the n, so let me just, Patrick, just put a page reference so that, cool, so that I can just later go and check that in the book and the reason why it is like that. And then it might be, so it would have been 10, then it gives you 2.5. So then what your book will probably say is that, so the important thing is just, you still need to round it off to that nearest whole number. Because here it would have now been 2.5. So you still need to round it off to the nearest number. Yeah, so always round it up. And I think that is, so again here, if we look at, so that is where the difference comes in, with the round it up. So where in this quartile, you will still get the value 8. So we would have gotten 8.25 probably. If you don't put 1, it's 32 divided by 4. So you would have gotten 8 in any case. So the rounding up is where the difference when just coming. You will always round it in any case up to the nearest one. So it doesn't really matter which formula you use, as long as you round it up for both. So again, else we sit here with 2.75. We don't want to work with 2.75. We don't want to work with 2.5. So always just round it up. And then if we round it up, it doesn't matter if you use the n+1 or if you use the n, because it will show to you exactly the same values. Okay, so we actually now have discussed, so that would have been 8 in any case. 8 would also be value 7, so that is also correct. Then the position and the value of the second quartile are both 5. Before we look at that, the second quartile is the same as the median. So second quartile is the same as the median. Okay, so Q2 is the same because if you look at it, it would have been n+1 divided by 2. So it would exactly be the same as the median. So now it's more of between the position of a value of second quartile versus the 8 value distribution is symmetrical. Okay, so let's look at the position and the value of a second quartile of both 5. Okay, so n+1, it was 11 divided by 2, which is 5.5. So if we said 10 divided by 2, we would have gotten 5. 1, 2, 3, 4, 5. See, so that now is where the big difference come in. Is it now that one? Is it that one? Is it between? So what I would have said is that is correct, because your position and your value is in the middle. It is 5. So let's look at the 8 value distribution is symmetrical. So for something to be symmetrical, it needs to be the bell-shaped curve. Okay, so let's now assume that is a bell-shaped curve. Let me just make it a bit bigger. So let's look at bell shape. So what I normally do with this data is I just group it a bit. So let's say I've got 1 here, I've got 2 and 2. 3 should have been there, 4 should have been there. Okay, then I've got 5, 5, 5, 6, 7, 8, 9. Why is Q2 divided by Q not 4? Okay, so remember 10. Oh, sorry. So it was. So I already simplified it a step further. So Q2 would have been 2 divided by 4. Sorry. So I already simplified it a bit further to say, well, okay, 2 goes into 2 twice, 2 goes into 4. But it should actually be 2 divided by 4. I just simplified it already even more. But you should have gotten, what is it, 22 divided by 4, which would give you also 5.5. And also, if you didn't say 10 plus 1, you would have gotten 20 divided by 4, which would have given you 5. So sorry, that is just, I just already made it a bit simpler for me. So yeah, so the easier one to remember is the 1, the 2, the 3, and you divide by 4. That's just for me always easier. So let's just get quickly back to this. So you can see for the bell shape that nearly this part and that part would have needed to be the same. So we would have said, okay, but the median mode is all in the middle. So out of study unit 6, 7, 8, when we look at the bell-shaped curve, that and that should actually look exactly the same. So for it to have been a bell-shaped curve, this data would have needed to look like that. It would have needed to be 1, 2, 3, 4 on the one side, 6, 7, 8, 9. So there's the 4 with 1 intervals in between, and the rest sitting in the middle. But it's not. So automatically this tells me that the data is skewed and it's not symmetrical. Okay, so I normally, and you won't get lots of data points, so I just try normally to write it down like this, just to get a view of how the spread of a data is, and important nearly to leave those 2 gaps open where the 3 and the 4 would have been. Because if you put it all together without that gap, then it looks very similar nearly. So I nearly keep the gap in just to visually, now I can see this side and this side is not the same. And out of study unit 6 and 7, with data being symmetrical, we know that the one side, what's happening on one side must happen on the other side as well. So here we could have seen it's not the same. So that is why option 5 is the incorrect one. Yeah, see, so that is just, and I think what will happen in the exam is, because they need to cater for both. So they need to cater for the n divided by, or the 2 times n divided by 4, and they need to cater for n plus 1. So for the median, actually, the correct one to be spot on should have been 5.5, and we normally don't round off the median, because we would have said what is what is between 5 and 5? And between 5 and 5 is 5. So what we normally would do is to say, okay, well, there's 5 numbers. There's 5 numbers. For the median, it is position 5.5. So not even 6, we would have said position 5.5 because it's in the middle of the two. Remember, there's another formula to work out the median, and that is to get the point in the middle, which is, so we say 5.5, but then to say, okay, what's the one value plus the other value? So 5 plus 5 divided by 2. So the median would have been 5. So that is another way nearly to get to the value of a median. So the median is nearly the only one that you don't round off, because if this was 5 and this was 6, the value in between 5 and 6 will be 5.5. But if you used the 5.5 rounded off, I would get 6. And if Patrick used the formula where it says 5, you would get 5. So the median is nearly the only one that you really don't round off, but you actually take the one in the middle. So that is nearly where Q2, Q1 and Q3 you round off, but the median you actually take the one that is in the middle. So just be careful with the median, and that's why you will not really see a lot where they talk about the position of the median in a lot of questions. Because of that, nearly I will take one option, you will take a different view on it. In the end, we will probably get to the same numbers, because what happens mostly is that your mode is also around that median. So you can nearly check all your, that whole pack that I shared over the weekend. Look at all those stem and leaves, and you can nearly see all of them. The median and the mode is very not seldom, nearly every time the median and the mode is the same number. So a lot of these data sets that they give us, the median and the mode is mostly the similar one. The one that might be different is the mean. And probably what would have happened with this one, because it's a bit skewed, your mean will not be 5, and you can probably go and test it, and it will probably not be 5. It will just be less than 5 nearly, just because of the skew in the data, and it might be just be more than 5 as well. Okay, so that was median. Mode, we didn't really have a mode, but if needed, we look at the position. They love to ask interquartile range, like you guys would have now seen in the mock exam as well. So anything around interquartile range. So if it is positions, if it is actually using the positions to get the interquartile range, nearly both of them can be asked. Just make sure, and I think it was in assignment 1, where, yeah, so another one to look at if it needs to be symmetric is mean, median, and mode must be exactly the same. So if your mean, median, and mode is not the same, it's also not symmetrical. So yeah, if mean, median, and mode is not the same, so let's, just for interest's sake, let's quickly work out what what the mean was. So it was 1 plus 2 plus 2 plus 5 plus 5 plus 5 plus 6 plus 7 plus 8 plus 9. Oh my word, it actually is 5. That is so weird. 5, 10, 15, and it is actually 50. It would have been exactly the same, but that data is skewed. Wow. Just check, but I think the sum is 50, so 50 divided by 10 is 5. So mean, median, and mode is exactly the same. Oh my word. And that is definitely skewed, if I look at that. That is 10, that is 20, that is 33, no, that is 50. Whew. Mean, median, and mode, all the same. Sure. And I don't even think it was supposed to be like that. Because here you can definitely see out of this, it is skewed. But with all three measures, it is, I'm going to take a picture of this, send it to the lecturer tonight. Because when it is this one, but when, again, Patrick, you would have said this one is correct because of how you would have calculated it by 10 divided by 2 and not 10 plus 1. I'm going to ask the lecturer on this one, just because according to me, that data is skewed, but according to all the other measurements, it's not skewed. Okay, I'll get back to you, but it should not be that that those three are exactly the same if you look at this. So so it is probably the second one, but then I just want to make sure that for Patrick's sake, I will just interrogate page 57 so that you don't make, because Patrick would have gone for 5 because of the n divided by. So let me
surely
just
the
make
eight-value distribution is symmetric. If you look at your graph as such, it's not really symmetric.
Exactly. So that's why if you look at the graph, it's definitely not symmetric. But we know out of all our other work, when mean, median, and mode is exactly the same, the data is supposed to be symmetrical. And so let me, maybe there was a mistake in this, and it shouldn't have been like that, because what might have happened is, and again, so if something like this happens in the exam, you tell me question 4, you feel there's something wrong, because probably what happened, because this was the first of the exams that was online, is that, or they probably changed it because, again, there's 3 or 4 options, and they might have changed one of these numbers, and by fluke, the three measurements stayed the same, but your data definitely has not stayed the same. So again, if something like this happens in your exam, please let me know, because that is what I would have wanted to see as an issue. Okay, cool. Let's go to the next one, because it can be that, again, there is 3 or 4 of these types where 3 of them works out perfectly, but one was changed and just by changing it, it actually didn't change a lot of underlying information. Okay, let's look at the next question. So again, the same data. Now, this was the first time I saw this in a paper. So where it was part of this component of work. So they ask which one is incorrect, and then they give you nearly probability type of questions, but they say, look at this data. 30% of the households received an amount of 2,000 at most. Okay, so 30%, we know there's 10. So 30% of them received an aid of 2,000 at most. Is that right or wrong?
It's right.
And 70% of a household received an aid of 7,000 at most. 1, 2, 3, 4, 5, 6, 7. So now, what is important is to say, because we're looking for 70% of the households, not 7. Okay, so one can easily make that mistake. The 70% of the households is actually that line because it's 1, 2, 3, 4, 5, 6, 7. 70% of households received an aid of 7,000 at most. Right or wrong? Okay, I'm gonna keep a question mark. 30% of the household received an aid of 7,000 at least. So 7,000 at least, 30%. So that's 1, 2, 3 of them. So that's correct. The 30% of household did receive at least 7,000. 7, 8, and 9. 3 out of 10 is at least. So that one is correct. We're looking for the incorrect one. Okay, so 70% of the households received an aid of 6,000 at most. 2, 3, 4, 5, 6, 7. 70% at most 6,000. Correct or not? Okay, also correct. Okay, so 70% of households received an aid of 5,000 at least. Okay, at least 5,000. So 1, 2, 3, 4, 5, 6, 7, at least. So 70% is right. Okay. So let's look at it again because so at least 5,000. So 5,000 at least is, that is at least 5,000. So there's 1, 2, 3, 4, 5, 6, 7 of them that have gotten it at least. So 70% of household received an aid of 5,000 at least. So that is correct. Read that one again. 70% of a household received an aid of 7,000 at most. So if I look at 1, 2, 3, 4, 5, 6, 7, at most, how much did they get? At most, 6,000. Okay, we been told that it was at most 7,000, which is not. If it was 7,000, you would have included that and then it was 80%. Okay, so very important nearly with this one, and what the catch is with this one, and it's very easy to make that mistake, is because the numbers is also nearly in 1, 2, 3, 4, 5, 6, 7. It's very easy to, we looked here at, that was value or value 7, but next to it is actually 7,000. So it's very easy to make that mistake when you're looking at. So what I would do if I were you guys, I would nearly say, but let's put in something that one can just nearly, and you can put in K, or you, when you jot it down, say 6,000, but this is very easy to make a mistake because you're looking at the 7, you're looking at the 7, and then you're looking at 70%. So it's like very easy. Even if here was a 3, I bet you a lot would then look at the 30% and the 3 and also make a mistake, because it's just so easy to make that mistake. So this is supposed not to be difficult, but by creating it with single numbers, so close, and that's why they're very clever in how they created this question, because the 30% is always around here, so it's always around the 2, or some of you might have a table where there's a 3, so it's very close in that range. And then the 70s is nearly all in this kind of range. Exactly, and that is the one where it is. When I first did this as well, it was like, yuck, but are they now asking this? Are they asking that? And trust me, how this is structured as well. Normally one read I looked at it and I'm like, okay, but the sentence construction is also not nearly correct for me, because I would have said 30% of household received an aid of at most 2,000, and not of 2,000 at most. So it's nearly, the sentence construction is not very nice. Then between that, at most, at least, which again, my home language is Afrikaans. So I'm like, ugh, what does that actually mean? Does it include, does it not? And that is nearly the same with things like less than, more than, less than, and equal to, so that you nearly, because those are the small things that in the end catches us out. Because this is, and let's be honest, if this was in, even in 70s or 10, 20, 30, then probably we would have also been making the mistakes, because then it's again, I would have read very close over 70% to that. So again, how they give you the data, it's not difficult data, but again, it's there to catch you out, instead of just testing if you actually know it. So this one I thought was, it's really not difficult, but I think we all nearly made mistakes as we went through to say, but 4 is correct. No, but 3 is good. Oh, no, but that one is correct. And it's very easy to make a mistake with this one, just because that at most, at least, then at least you nearly need to work it the other way around. So work from the bottom up kind of. So yeah, very, very difficult in this one, actually, with how they wanted to catch you out. So hopefully now that we've done it, it won't happen in the exam. Okay, the next one is, again, looking at the same data, looking at range, interquartile range, standard deviation, sample variance. So this one, and sorry for the 1510 guys, we're gonna still see how we can assist you. But this I would have probably put into Excel, because again, easier for me. Well, I would have done something different, so I will show you guys what I would have done. So also the 1510 guys, this one I want to show you guys as well, because there's a nice shortcut with this that I would look at. So yes, we can work out the range, interquartile range. Please don't use Excel for interquartile ranges, because Excel uses, and that is also what was shared on one of the on the chat today. Excel uses the formula of a 2.75. So if Excel does quartiles, interquartile range, it will work it out wrong. So please don't use Excel for the interquartile range, because unless you're lucky with the data, else, like we've seen today on the chat, just by using it slightly different, we don't get the option. So interquartile range on Excel doesn't really work. So please don't use that as an option. So so we wouldn't have known about interquartile range if it's correct, unless we nearly went back here. What was Q3 was the value of 7. Q2, the value was 2. So 7 minus 2, yes, perfect. Interquartile range was 5. So again, you guys probably would not have written that down, because that's not something that I would have thought would come up again. So my shortcut is, we've got a standard deviation, we've got a variance. So out of our rules, we know that the square root of your variance must be your standard deviation. So we know that by asking us in this question, which question is incorrect. So if I get the variance and I use that, the 7.111, I take the square root of that, I get 2.667. So if my variance was wrong, then that would have been wrong as well. And then more than one is incorrect. So I know that if that and that is correct, that standard deviation is actually the wrong one. So I could have just looked at those three and said, well, one of the standard deviations must be wrong. So which one is wrong? The one that doesn't fit with the sample variance, that one is the one that's wrong. So if you had two sample variances and one standard deviation, again, you kind of work it out to say, well, I've got one sample variance, I've got two standard deviations, or I've got two sample variances, one standard deviation. Both can't be wrong. So only one can be wrong. So which one is wrong? So for the 1510 guys as well, that for me is even easier than now going to Excel, putting all the data in, then say, okay, sample variance, sample standard deviation. Here I just saw that one must be incorrect. So one of these two sample deviations or standard deviations must be incorrect. If this was a question, that's your last question, you've got 30 seconds, then it is one of those two is incorrect, guess one of those two, or if you have just a bit more of time, square root that, see which answer it's not linked to, and then say, okay, but that one is the incorrect one. So nearly in this one, trying to show you another way of saving time, because again, you didn't need to work out the range, you didn't need to work out the interquartile range, you didn't need to work, yes, we've worked with, but we know that that can't be, because one needs to be wrong. So nearly with that, it might be that, and again, to work out the range was easy. To work out the interquartile range, if you didn't write it down, now again, it takes a few minutes. If you used Excel for the interquartile range, you probably would have gotten, it might have been the same, but they would have used this as 2.75 times, so it might have been different. So just be careful also in the exam that, especially with interquartile range, Excel is by definition, it takes what the definition is. By definition, we should actually say 2.75, but again, it is just easier to round it off, and that is how all the answers have been created as well in this study you did. Okay, so coefficient of variation now. So they give us the data. Again, remember coefficient of variation. I hope that is the right formula. I don't always remember it. Is it that way around or other way around? So it's normally the standard deviation. So normally the sample, we work with a sample deviation. So it's that one times 100. Again, what is not great is if you did not write down here what the sample deviation was, now you would have needed to work it out again, which is not great. So I would have liked to see, but that they at least here give you some measurements because you would have worked it out previously. You wouldn't have worked out the mean. We did work it out for just checking this the symmetry. So that would have been your formula. So the coefficient of variation would have been as 2.667 divided by 5 times 100, which gives us the 53.3%. None of the above will be, there's, I think in most of the stats questions that has been removed because it's, we did complain a lot about that one, just because it's really not great if all your answers, the fifth option is none of the above. So you don't really, you can't take shortcuts, you can't really, because if there was an error somewhere, they could have just said, well, there was an error in the question, you should have picked none of the above. So, and I think none of your assignments did have none of the above as well, nearly in it. Okay, so coefficient of variation, they love to ask that. So again, if you didn't get it in the mock exam, then it's nearly an indication that you guys will get it in your exam, but they love to ask it because in there they test nearly two more things. So it is that you know how to work out the standard deviation, and you know how to work out the mean. So again, it's by covering nearly 2 or 3 things in here with one question. So again, they love to ask things like this. The same with, again, with that interquartile range or the quartiles, they nearly test more than one concept within it. So then they don't nearly need to split questions up. So nearly, just be prepared for those kind of things. Okay, so now we've nearly the last few. Once this was which one is correct, which one was incorrect, incorrect. So now we get to statements. And again, this might be, so if you get a lot of statements, what can happen in the exam is that a few of you will get the question as pick the correct one, and a few of you will get the question in the format of pick the incorrect one. So again, if you get a question like this and you feel that there is nothing that's correct, it might have been that it should have been stated differently. So then you let me know, John, question 8, there was things that it just felt like the definitions were wrong. So that's all that you do. So afterwards, so while you guys are writing, since you are writing down things, just make on the side a note and say, okay, question 8 was maybe not a cool one. Maybe it is that you were caught out, but let's just make sure that rather that you were caught out when there was an error. So, so when it is, there's nothing prohibits me from asking the lecturer afterwards to say, please just check questions 8, 10, 15, because there was some worries about it. And then if it was correct, it's fine, but rather let's just make sure around those things. So question 8, which of the following statements is correct with regard to negatively skewed distribution? Sure, negatively skewed. Hopefully you guys, there's a nice picture in that my doc summary that I sent you guys. I think I drew negatively skewed, positively skewed, all those things together. So let's look at all the statements. So the mean is less than the median, and the median is less than the mode. The mean is greater than the mean is greater than the median, and the median is greater than the mode. So that too is nearly just the opposite. Let's just read those two again. The mean is less than the median. The mean is greater than the median. The mean is less than the mode. So basically those two are the opposite. So sure, I'm like, can both of them be correct? No. So one of them is correct, the other one is not. So again, if I would have guessed, it's one of those two. Let's just look at mean, median, and mode are all equal. Okay, so that is not correct because that means asymmetrical. The mean is greater than the mode, which in turn is greater than the median. Okay, so it's a bit different than those two. The mean is less than the mode, which in turn is less than the median. Okay, wow. Okay, so those two are also just the opposite. Okay, so let me quickly show you. So I want to get that from, it is in the study guide actually. Let me quickly get that from exactly from a study guide. Because again, this is not something that I think any of you need to remember at all. Because it's really not. Let me quickly. Let's get to page 34. Let's get to. Okay, so let me quickly also show you. So, and here you can from a study guide, and I think when you look at page 23, Patrick, and that is nearly where we have the interquartiles. So the Q1 represents the 25%, so that's where the 25 out of 100 comes in. But here they definitely talk about use these formulas. So nearly look at what is it, page 23, and rather follow those ones, because when you exactly what we looked at, and then probably that other one is still, I feel it's not symmetrical, but so also in here, let me quickly page, where was it, 34. I just want to get the, okay, so also page 32 is your coefficient of variation. Okay, so from page 33, measurements of distribution. So bell-shaped, mean, median, and mode, all the same. Okay, negatively skewed, which is what we have. The mode. Okay, so let's do it this way around. The mean is, let me just quickly. Okay, sorry, this is positively skewed. Positively skewed, the mean is greater than the median, and the median is greater than the mode. So if it was positively skewed, option 2 would have been correct. Negatively skewed, the mean is less than the median, and the median is less than the mode. So nearly make again a flag on this nearly if you get anything of positive skewed, negative skewed. What they can also say is positive skewed is a tail to the right. So they can use right tail versus left tail as well. So I think I will just look at my notes again. I think I did mention it on there, but so this is purely definition out of study guide. I think for us to nearly look at this question, so that was the one that is the correct one. See, what's interesting about the last one, so the order is mean, median, and mode. So that is for order of how it should lie. If you look at this, and that is why I also marked it, but you see, so the mean will be greater than the mode, so that is probably when it's positively skewed, the mean will be greater than the mode, but the mean will not be greater than the median, so, or the mode will not be. So the order is nearly important, and that's why both those were incorrect. Even though it looked like the one is the opposite of the other one, both of them are wrong. So important that in this instance, negatively skewed, mean is smaller than the median, which is smaller than the mode. So that is negatively skewed. Positively skewed, it would have just been the other way around. Mean would have been there. The median is always in the middle. And your mode would have been on this side. Okay, so that is nearly, so yes, first one is the correct one. Please don't try to memorize this, because they can just throw it around a bit. So again, what I would nearly suggest is, again, make somewhere a note if you're looking at negatively, positive, and bell shape, and say it's on this page or something like that, because what they could have said as well, so we now said mean, median, and mode must be in that order, but they could have said the mean is less than the mode, so that mean is less than the mode, and the median is also less than the mode, because the median is also less than the mode. So they could have changed it a bit, so that it doesn't sound like it's in order, but it actually, we've now seen so many times with a lot of these questions that by just swapping it around a bit, or bringing in not, or say greater than, or and suddenly it feels to us it's something different, but can actually mean the same thing. So you can always say and make that note as well. It will be nearly less than that, but they can write it a bit different. So they could have said the mean is less than the mode, the median is less than the mode. And you can still get the same answer. Okay, so question 8. So this was again part nearly of looking at your central tendency questions about mean, median, and mode. So that was still study unit 3. So between study unit, so it was 1, 2, 3, 4, 5, 6, 7, 8 questions. So two, a bit more actually because they combined. So again, 2 or 3 questions per study unit. Okay, the next one we go into probabilities. Probabilities, what I normally will first look for is mutually exclusive. I think this is similar to one that we did previously when we did probabilities. It feels very similar because there's 2 independent ones that we need to work out. But again, I would have first look at mutually exclusivity because that's the easier one. So if events the UK and female are mutually exclusive, that would have been 0. Okay, so because that's not 0, there are actually people in the UK which are female. That sounds so weird, but yeah, so that one is not correct. Okay, so then the events female and male is not mutually exclusive. In this instance, we only had the categories male and female. We did not have binary. We did not have any other categories. So according to this categorization, you can't be male or male and female unless the way it could have been is if you look at this total and that was 265 and that was 320. You could have said, okay, but wait, here is 5 more. So it might be that they are male or female. So yes, then they are not mutually exclusive. But look at the total. So if the totals add up to the final total, somebody couldn't have been categorized as both. So male, female in this data are not mutually exclusive. Okay, so which is also incorrect. We're still looking for the correct one. Okay, before we go to work out independence, let's look at if events UK and female are independent, then UK and female must be equal to 0. Again, incorrect. It is if events UK and female are mutually exclusive, then UK and female will be equal to 0. So not independent, mutually exclusive, so still incorrect. Okay, so now it is, unfortunately, we will need to multiply out. So if events AU, so Australian, that is 102 divided by 580. So if the 2 are independent, remember that we say AU times female, which is 260 over 580. So if those 2 are independent, it should be equal to the AND. So Australia and female. So let's just quickly female Australia. So then it should be equal to 52 divided by 580 if it is independent. So 102 divided by 580 times 260 divided by 580. So this answer I get as 0,079. And if I say 52 divided by 580, I get 0,089. Okay, so those two are not, or that is not the same, so it's not independent. So option 2 will be the correct one. So let's just see UK and female. So UK is, and let's write it here, 390, 19, sorry, divided by 580 times female, which again is 260 divided by 580. And that should then be equal to UK and female. So that should be equal to 143 divided by 580. Okay, so let's 319 divided by 580 times 260 divided by 580 gives us 0.2466, and 143 divided by 580. 143 divided by 580 gives us also, okay, 0.2466. Okay, so we know the two is similar, so we can say events UK and female are independent. Okay, this one, just because it was in the previous one, I knew which one was, or which between which two was the incorrect and the correct one. But again, there's not really any shortcuts to take, because we could have those two, we didn't need to work out anything. So that is why I nearly want to make sure that whatever the statement is, that it wasn't one of them. The same with option 5, didn't really need to work out anything. But between those two, because it's independence, it does take a bit of time to work it out. So again, if this is in the exam, unfortunately, yeah, nothing in here that tells me I must eliminate certain ones. This one is again one of those that unfortunately you will need to work out, and hopefully the question is structured like that you might be lucky that one of them is quicker to solve. So that it might have been that one of the mutually exclusive ones was the wrong one, or the last one was the wrong one, so that you don't need to take the time with working out option 1 and 2. Okay, so that is a question on probability. You will get something on probability where they test your understanding of independence and mutually exclusive. It is just, it will be there. Okay, so this will be in some way, this will be in the exam. Then also what they normally would ask you is, again on probability, is, okay, so we've got mutually exclusive, we've got independence, we tested that. So the only other thing that we can ask around probabilities are that you know how to work out the and, you know how to work out the or, and you know how to work out, if I tell you, work out the probability of UK given a certain in this one, certain gender. So that nearly is the two things that they can ask you in the exam. The one will be around independence and mutually exclusive, and the other one will be around the ones that we left out nearly. So can you work out a or? Can you work out a and? They might even throw in a complement here as well, where the complement is 1 minus what the probability is. So those are the things that will be asked in the second question around probabilities. Okay, so here they tell us, okay, again, I think this was highlighted in a previous one that we went through, but let's quickly look at them. So which of the following is incorrect? So probability of M, so probability of male is equal to the probability of UK. So you can see those two are very similar. So if we're going to say 320 divided by 580, and if we're going to say 319 divided by 580, we are going to get the same answer. So yes, you can work it out, but that 1% difference is not going to make a difference if we round off to 2 decimals. Okay, but you could have worked it out and just say 320 divided by 580 and see what you get, and 319 divided by 580 and see what you get. Okay, then second question or second option, the probability of AU and F, so AU and female, 52, AU and male, 50. So again, 52 divided by 580 and 50 divided by 580, and we round it off to 2 decimals, will give us the same answer. So yes, test it to make sure that when it starts being more not similar, so that between the 52 and the 65, so that's 13 people. 13 people on 580 is nearly a percentage or two. So, but between 1 or 2 people and you round it off to 2 decimals, you're not going to see a difference. Okay, so now we come into the other one. So UK and M. So I don't know what that is. So 160, 176 divided by 580. So 176 divided by 580, we get 0.3, 0.3034. So if we round it off to 1 decimal, it is correct. Okay, so still not gotten, so okay, went through 3 already, not one of the incorrect ones. Okay, so probability of UK given male. Okay, so how I always remember this formula is to say, okay, what I'm going to work out, what's the probability of UK and male divided by what's the probability of the last one, which is male. So probability of the 2 divided by the probability of male. Okay, so UK and male is 176. So 176 divided by 3, and probability of male 320 divided by 580. So what you could have done already is to say, well, those 580s is gonna cancel out. So you could have said 176 divided by 320. That gives you answer. So 176 divided by 320, 0.55. Okay, so again, correct. At this point, then I would say that is the incorrect one. I would not work it out, because what if you work it out and it's correct? Then you probably will go through all of them again, nearly to see So I would at this stage say, okay, that must be the wrong one. But again, if you needed to work it out because one of the others was wrong, probability of UK is 143 divided by 580. Sorry, that is the probability of UK and male, UK and female. So I just took a shortcut, divided by probability of female, 260 divided by 580. So 143 divided by 260 must be my answer. And that is 0, well, also 0.55. Oh, it's exactly, that's weird. So the two are exactly 176 divided by 320 gives us exactly the same as 143 divided by 260. Okay, very strange, but that is, so option 5 was the incorrect one. Okay, so this one also, yeah, not difficult, but time consuming. Because what we probably would have done in the exam is to say probability of male. So you would have probably said the 320 divided by 580 and then worked out the UK of 319 divided by 580. Even though it's very close to one another, you probably would have worked it out just to make 100% sure. 3 we needed to work out, 4 we needed to work out. So only nearly after doing all 4 sums, we could get to the last one that is incorrect. So again, not anything that we can nearly eliminate, not anything that I could easily pick up is wrong. So again, not difficult, but time consuming. And this is 1, 2, 3, 4, 5, 6 nearly sums that you needed to work out before you got to the last one that was the incorrect one. Yeah. And yeah, again, to try and use Excel for something like this, where what you could pre-code in Excel is probably what's the probability of female, probability of male, probability of any of those 3, but then to now pre-code all the possibilities in here, and you only get 1 or 2 again. I would not use Excel for this. So nearly up until this point, I would probably not have used Excel for any of the calculations. So yes, it's a luxury to have, but in some of the instances, it just takes also a lot of time. Okay, so let's go into the next question. The start of study unit 5. So again, study unit 5, you will most likely get a question on discrete, like this one, a type of binomial question, so a bit different than we used to, and a Poisson. And then that was the end of your first session. So let's look at a discrete. So in here, they have, this is where I probably would have started. So in here, you look at the question, you need to work out what's the expected values, you need to work out probabilities. You can't have an expected value of two different numbers. So this one, I would have gone straight to work out what your expected value is. And your expected value is always x times the probability. So that would have been 0. That would have been 0.15. So again, you can use Excel, but sometimes it's also as simple as 2 times 0.2 is 0.4, 0.75. This one is probably more difficult, but 0.35 times that is 1, I think 1.4. I'll check it out later. So hopefully then one of those are. So 0.15 plus that one is 0.9. Plus that is 1.3. Plus that is 2.7. So the one that's correct is 2.7. Okay, so again, nearly showing for you guys that sometimes just scroll through the options. Like that other one, there was 2 standard deviations. We know both can't be correct. The same year, both variances can't be correct. Okay, so expected value. So one of them must be wrong. So yes, great. We can work out probabilities. I'll show you now how we would have done that. But for the exam, don't even go there if it's not needed, because you can go straight to those two because one of them must be incorrect and one will be correct. Okay, let's look at the questions around the probabilities. So the sum of all the probabilities we know must be equal to 1. Okay, they said it's not equal to 1. Okay, so that is incorrect. So remember that was all incorrect and that one was correct. So probability of x smaller than 1. Okay, smaller than 1, not including 1. Smaller than 1 is just that. Here it was, if it was smaller or equal to 1, then it would have been 0.2. It's not. It's just smaller than 1. Smaller than 1 is 0.5. Okay. Probability smaller than 3. And sorry, smaller and equal to 3. So it includes 3. Bigger and equal to 1. Bigger and equal to 1. So it includes 1. So it's 1, 2, and 3. So it is 0.15 plus that is 0.4, 0.6. Okay, and they said it's only that one, but we actually need to include 1 and 3. That's why that one was also incorrect. Okay, so just if needed, but again, in the exam, please spot that those two can't be the same and then move on to only trying to solve that. Okay. Binomial. Interesting one. So this is looking at the formula, and this is looking at certain different probabilities. So very important in this one to read the question. The South African Embassy in Sydney knows that voters' turnout rate is 91% at their station. In a random sample of 20 voters, what is the probability that at most 13 will turn out? Hint, we talk about 20 voters, independent trials can either turn out or not. So basically what we're telling you in the hint is that we're working with a binomial. Okay, 91%. So that is, now that you guys, what normally would have happened if this was not online, they would have given you just, and let's, where that was study unit. So where's I just want to see if the tables is at the back of study unit. So if this was the olden days where it was not online, you would not have gotten a binomial with all of these. They would have just given you binomial that n is 20. So here we have n is 20. We looked at 0.91. Okay, so we're looking at from bottom upwards. So how we look at it is that will be my n0 or x0, x1. So there was n x13, but what do they say? Let's just read the question again. But in a random sample of 20 voters, what is the probability that at most 13 users or 13 voters, at most, so 13 and less. So let's just, again, there's no easy way. Maybe if this was printed, I could have now gone and, so at most is that plus that plus that. So 0.0011, 0.0002, and 0, so 0.0013. 0.0013. If you did it the other way around, where you said you added all of those together, you would have selected that answer. So if you did it the other way around, there would have been an answer. If you looked at only 13, probably not. So luckily only 13 there is not, unless you read, but then also there wouldn't have been an option. Okay, so mostly the two differences. So if they give you probabilities as well, then I would first go to the probabilities and check if there's an answer before I try to make sure about the formula, because what this would have done is not worked out. So this would have worked out, you can see it's using the right things, but that's working out at one point. So that would have worked out the probability at 13. So that answer would have been 0.0011. If you would have needed to say, plus what's the probability of it being 12, what's the probability of, so again, this one is, if it was, what's the probability that only 13 voters will turn out? That would have been right. Okay, so again, nearly look at it from that point where if it's more than one that we need to calculate, this formula must be also more than one binomial, because this one works it out at exactly that point. So that's why if we need to work out binomial, why we nearly avoid this, because if I now needed to work out that, I needed to work out 3 of those formulas, which will really take long. Okay, so that is that was the binomial one where option 5 is correct. And then the last one for tonight, Poisson. So, and that covers basically in our first section as well. So study units 1 to 5. Suppose that the number of voters entering a voting station in the UK per minute is Poisson distribution with a mean of that. Okay, so if that is the mean, that is also the variance. So remember that nearly as the first thing, because before I even go into tables, I'm gonna check for that. So the probability, probability, if X is the number of voters entering a voting station, the variance is, okay, so it's correct. Which of the following statements is correct? Okay, so there it was actually the correct one. So that was the easy one. So again, nearly the questions will be balanced so that yes, it's going to be a very tight push for timing, but it will be balanced that this should be very easy. 1 minute for this question, because really look for the things that are easier to calculate. Else now we need to go to the table and say, okay, no, it's not that one. Okay, no, it's not that one. No, it's not that one. No, it's not that one. So instead of the whole time going to the table for Poisson, this is nearly the first thing I would look at. If in binomial there was the mean or the variance, again, I would have probably looked at mean and variance first, because again, that is a much easier calculation to do than to go and try and see first on. So I would have probably, if it was, now I'm writing mean like that, which should not be, it's expected value. So, but I would have probably worked out if there was an option of the mean and the variance first in binomial. So the same in Poisson, I go for variance first, and then only after that we'll look at my probabilities. So if that one was incorrect, then unfortunately we'll probably go back to, and then I'll look at the ones that first exactly for that no one. So then before I nearly need to start to add things together, I will then look at, okay, exactly 4. So that is where X is exactly 4. That's easier to get than to get between 2 or 3 numbers. Okay, so that is it for tonight. I'm going to stop the recording so that I can still put it on the